Hello and welcome to part 4 of Rust for Beginner series. In this video, we will be taking a look at crates, modules, paths, packages, and workspaces. Also, we will modularize our project by dividing our code into various modules and workspaces. So let's begin. A crate is the smallest amount of code that a Rust compiler considers at a time. We can even run crates using Rust C, whereas an entire project requires cargo to run. A crate can be of two types, a binary crate or a library crate. Binary crates are programs you can compile and execute. Every binary crate must have a main function, which is also the entry point when we run these crates. Library crates don't have a main function and they don't compile to an executable. Instead, they have functionalities which help our binary crates. For example, the IO crate that we have been using to take the input from the user. By dividing our code into modules, we can create it more readable and make it more reusable. Modules also allow us to control privacy, as everything within a module is private by default, and we can allow what we want to share with other crates by making them public. Now let's jump to the code and see the different ways of creating modules. So creating a basic module is as easy as typing mod keyword and then defining the name for the module. After that, within curly braces, we can write any code and that code will be considered the part of that module. So here we have created a DNS module in which I have moved all the code which we wrote related to DNS in our last video. Now in main function, to call that work function which we just created within the module DNS, we can do DNS and then all the public members of the DNS are accessible. But our work function was private, so first we need to make it public and then we can call it within the main function. We can also make struct enum or anything that we have defined within the module as public based on our needs. Currently we are able to access this DNS module because it is within the same file as our main function, but when we move this to another file, we will have to make this public. Now let's see how we can create modules based on files, because if we just create everything within one file, it is almost unreadable and unusable code. Okay, so first up we just create a file called dns.rs and then we move all this DNS code within that file. Let's also change this to smaller DNS because the file name which we used is with small letters. Now every crate that we create, which is this file, is a module by default, so we don't really need to define this mod DNS at the top. This mod DNS is currently creating another module within the DNS which we don't want, so we will remove this. And then to make this code accessible within our main file, we'll do mod DNS. So this mod DNS is basically bringing the DNS module within the scope of the compiler. We need to do this only once, and once it's accessible to our compiler, then we have different ways of accessing it. As I said earlier, we can also define other modules within a module as well. So let me create a new module test within the DNS module so that I can show you exactly that. Now just like before, we need to make this public, otherwise we won't be able to access it. Now as you can see here, we also have test visible in our IntelliSense. Next we'll make the test function also public, and after that we will be able to access that function as well. But this was just an example, so let me remove all this. But what if we want to divide our code within subdirectories? So for that we'll use this rectangle code as an example because we have multiple functions as well as struct. So we'll create a new file called rectangle.rs. This is one of the way of declaring all the modules within a subdirectory. Now let's create a new folder called rectangle. The name of the folder should be same as the name of the file, which will access the entire subdirectory. Now within the rectangle file, we can create as many modules as we want. So first we'll create a rectangle struct module. This will just have the structure of the rectangle. Next, we will declare this rectangle struct module within our rectangle.rs file. And not just this module, we will declare all the modules that we will be creating within the rectangle folder. Now let's transfer our struct within the new module. And then we'll declare the rectangle module within the main file. So now our main file is accessing rectangle.rs, which is then declaring every module within the rectangle folder. After making everything public, we should be able to access our struct. Next up, we'll take all this code from main function and create another module for this. So let's create a new file, rectangle_work, and make a public function within this. Next, just like before, we will declare it within our rectangle.rs file, which will give us a bunch of errors. Because we had declared the path for IO within main.rs, but we have not done the same within the rectangle work file. Next, we can see that our rectangle is also giving an error. We have our rectangle within rectangle struct folder, which means we cannot directly use this, but we can add rectangle struct before rectangle to access that. Okay, next we are getting this error in height and width. This is simply because we haven't made these fields public yet. So we'll go to our struct and make these fields public as well. Next, we have some errors when we are calling these functions. Same reason as before, because we haven't made them public yet. And with this, we have divided our code within multiple files with different directories. Finally, we'll go to our main file and call the work function for rectangle modules. Creating a file and folder with the same name and the file defining all the modules within a folder is the new and preferred way of defining modules within subdirectory. But earlier we used to have a mod.rs file. Now the use of mod.rs file is still allowed and is also used by a lot of developers, including me, as it was the first method that we learned. So we'll take a look at that as well. So for that, we'll create another directory called basic, and within this basic directory, we'll create a file called mod.rs. Now this is the file where we declare every module just like we did in rectangle.rs. So let's cut the remaining code, which is all the functions and logic, and paste them into a utils file within the basic subdirectory. Now just like before, we need to declare utils within our mod.rs. Let's also create another file called work.rs within the basic directory and paste all the functions from the main function of the commented code. We'll also add work to our mod.rs. And finally, we will add the basic subdirectory as a module within the main file. And that's how we use the mod.rs file. Now we still have a lot of errors within utils and work, and those are primarily because of the path. So within our utils file, we can just do use std::io. This will make IO accessible within the file. But we can also add std before the use of IO, which will also do the same thing. But since we have multiple instances of IO being used, so we'll just declare that at the top. Next, let's go to our work file. Now, first up, we have the same error with IO, so we'll just add std. Next up, we have errors on the functions, and the first thing we need is to make functions within the utils public. Now, we still do have all these errors because the compiler is unable to find all these functions. Now, to define the path for, let's say, swap function, we can use super. Super is defined to go to our parent rate, and from there we can define the path of our function. So after super, we can do utils, and then we should get our swap function. But super is used to define path relatively. And if we want to define absolute path, then we can use create. So in create, since we are defining absolute path, we will first go to basic, then utils, and then even odd. We can also use a use statement, just like how we did with IO. Now within use, we can either use relative path using super or absolute path using create. Once we have utils, then we can simply go utils : sum of natural numbers. We can not only import create using use keyword, we can also get functions. So after utils, we can also do : and then the name of the function. Once we do that, we can access that function directly without defining any prior create or module. Let's call this basic work function within our main file. Okay, let's suppose we need two functions from within utils. So what we can do is use basic utils, and then we can define name of the function, create variable, or anything that we are importing from that module within curly braces. In our case, we have imported even odd sum of digits, and then we are able to use them within our main function. A package is a bundle of one or more crates which contains a cargo.toml file. This cargo.toml file is incredibly useful as it defines how to build those crates and also allows us to add third-party packages within our project, so that we don't need to code every little thing on ourselves and use publicly available packages to boost the features within our project. So this is crates.io. It has all the publicly available packages that we can add to our Rust project. And I will be using Exam as an example to show you how to add a package within your project. So you can see you have this install command cargo add exam. You can use this, or you can just copy paste exam equal to version number of the package. I will show you both the methods, but first we'll try the copy paste one. So we simply copy this line and then paste it into our cargo.toml within the dependencies section. After that, we should be able to use exam within any of our modules. And here you can see that I'm creating a router using exam and it's not giving me any errors. But as soon as I go back to my cargo.toml file and remove that line that we just added, we will be getting some errors. And now it doesn't recognize this exam. Now let's open up terminal and run the command to do the same thing. So for this, we'll do cargo add exam. Now this does the same thing as copy pasting that line, and if we go to our cargo.toml, we can see that it's the same thing, but it has been done using a CLI. When we are working on a large application, a single package, even with a lot of modules, might not be enough to make the code sufficiently modular and readable. In those cases, we can divide our code within different workspaces in a single project. Now, every workspace in a project have a different cargo.toml file, but all of those packages have a common cargo.log and a common output directory. Now let's see how we can create a package within our project as well. To create a workspace, we can just create a new package within our current package. So we'll do cargo new workspace. And you can see in our cargo.toml, cargo has already added that workspace. Now this is fine, but I would like to reformat it a bit because this does not look as clean as I want. Next, we'll need to add path for this workspace. Since it is in the same directory as cargo.toml, we can just do path equal to new workspace. Now we have a main file within the new workplace. Now we only want this workspace to provide functionality to our main workspace. So we will remove this main function to make this crate a library crate instead of a binary crate. Let's also rename this file as work.rs instead of main.rs. And then we'll simply add a mod.rs. Now mod.rs is just an example. You can create modules in any of the ways we talked about a few minutes ago. Now in cargo.toml of this new workspace, we will create a lib section and give it a name and path. The path will be of the crate that is the entry point of this workspace. Now with this, the setup of our new workspace is complete and we should be able to access it within every crate of the main package. Now you can see if I go to main.rs and do new workspace, we are getting some recommendations, which means it is able to find our workspace. Let's go to our work.rs file in new workspace and put a simple message there to identify that this code is from new workspace. After that, if we run this and scroll to the top of our output, we can see that this is new workspace is being printed at the top, which means our new workspace code is working. So by now you should have a good idea how to manage your packages. And with that, thanks for watching. Please give a thumbs up if you liked this video and do consider subscribing.